Then we distributed this, so we get, so 3, negative 3 times radical 2. This one doesn't have a radical, so we're not timesing 2 and 3, 3 and 2. Instead, we're just going to write them next to each other. Negative 3 radical 2. Then negative 3 times radical 5. The 3 doesn't have a radical, so basically we just write in, so plus, negative and negative is a plus. 3 times radical 5 is 3 of radical 5. Then we get to distribute these. All these have radicals. That means we will multiply what's inside, the radicands. The radicands is what's inside. So radical 2 times radical 2 is radical 4. Then what's radical 2 times radical 5? What's radical 2 times radical 5?
Radical 10.
Radical 10.
That's right. This time we can multiply 2 and 5 because they both have the radical of the same index. Index is invisible too. It's a square root. So radical 10. Then this one, radical 5 times radical 2, that's radical
10.
That's right, 10 again. Finally, radical 5 times radical 5, the sign is negative. Radical
25.
25. And simplify if you can. Can we add these two radicals?
No,
No, we can't because
we have different radicals.
that's right. The number inside or the radicand is different, so we can't add these two. This basically has to be the same number here, just like, for example, x here and x here. These are different terms, so we can't add them. Just stay the same. Unless this 5, instead of 5, we had also 2. If we had radical 2 and radical 2, in that case, you can add them or subtract. In this case, they will cancel out. But it's not a 2, it's a 5, so it stays the same. For this, radical 4 again is
2.
2. And what else happens to the denominator?
Cancel out.
That's
Cancel
right.
out negative radical 10 and positive radical 10.
Exactly. So these cancel out because they have opposite signs. That's the reason actually we switch the sign in the conjugate from plus to minus or minus to plus. So we could have the middle terms cancel out. If you don't switch the sign, if you keep it a plus, these two will add up. It will be 2 here, 1 and 1 will be 2 radical 10. And finally, this one, of course, is 5. Then, did we do anything wrong? Okay, so this will be 2. We believe we made a mistake in the previous example. We turned this into, we kept it as 4, right?
Yeah.
Okay, all right, so this now turns into negative 3. And this will be, this stays the same. There's one more thing we can do here. We can simplify a little bit more. Can someone tell us how to simplify this a little further? Think about all those 3's.
You could multiply by 3 or divide.
Of the 3 from the numerator and the denominator.
Okay, what is that process called? So we have that 3 here. You want to cancel the 3, right?
Yeah, the negative.
But what do you do here first in order to cancel the 3 against the 3 from here? What is the operation or the process?
What is it called?
Basically, you want to move 3 to the front, right? What do we call that process?
I don't remember.
So this one is a common number, right? A common number or a common
Number.
What's the other word? A common
Factor.
Common factor, that's right. So we're going to factor out the 3 first before you cancel it against this. You can go ahead and cancel it out right away. But maybe you want to factor the 3 out first with a negative 3. So let's move the negative 3 over to the front and divide by negative 3. If you divide this by -3, what's left? Or if you move the
Radical 2.
radical 2. Now, if you divide this by -3, okay, by -3 will be positive divided negative, which is?
-1 radical 5.
That's right, negative radical of square 5. So we moved that -3 to the front. Why did I move the -3? Because they have a negative here. If this was a positive, I would just move +3 to the front. So again, factor -3 and simplify. And now we can go ahead and cancel those two out. Can do that. And what's left is a much nicer expression with less confusion. Okay, so again, that's what we call rationalize. So the question was, rationalize. The original problem was, let's say this. That's what the question was. Okay, rationalize this problem. So we wrote it again. So rationalize again means getting rid of the radicals from the denominator. So in order to do so, we multiply the bottom by itself, but we switch the sign inside. So we call this the conjugate of this term. So make sure you change the sign in the middle into the opposite sign. That way, after you distribute, you can cancel out the terms in the middle. You see how we have opposite signs here, minus and the plus. Those cancel out. That's basically how we get rid of the radical. These two become perfect radicals, turn into integers or whole numbers. Okay, so basically this expression is the same as this, but this one looks less complex. It doesn't have, it's not a fraction anymore, but they're exactly the same. Okay, so if you do this in the calculator, evaluate this, it will be the exact same number as this. That's the decimal will be the same. Okay, so that's the reason we rationalize, basically to make expressions simpler. In a lot of cases, you'll see a radical like this, and after you simplify it, you may end up with 2, for example, by itself, or maybe 3, or something like that. So instead of having a complex expression like this with a radical, if you rationalize it, it turns into something either like this, or like I said, in some cases, you end up with just one digit, okay? One simple digit. So that's the reason we rationalize expressions. Okay, and this will be the final answer. You may still end up with a fraction. You may still end up with a fraction, but that fraction will not have radical. For example, you may end up with something like this, which is fine. As long as you don't have a radical in the denominator, that means you rationalize your radical expression. Okay, you guys got that?
Yes.
Okay, everybody else? Does that make sense?
Yes.
Yeah.
All right, so that's basically how you rationalize radical expressions. Again, for those who just joined us, there is a new lesson plan. You have a couple more topics left for the semester. Let's see. Any other questions, everybody? Please let me know.
I have a question.
Mhm.
75, same
S-
chapter and everything.
Same chapter 75, right?
Mm.
All right, so
Question is 75, but the same unit and blah, blah.
75. Maybe we can spot a similar problem. Okay, look at 76. Do you see that? Are you looking at 76? It's similar to 75.
Actually, my question is that I really do not understand. Is the denominator? It looks looks complicated. I don't know. It looks like.
Okay.
Is it the square root? Is the 2 small, or is it just a whole number 2 then radical y?
2 times radical y. It's not
Okay.
it's not the index. It's 2 times radical 8.
Okay.
If that was, let me actually write it over here. So we're going to do the same way we just did. So this is would be question. So question 76, which is similar to 75. So you're doing 75 for the homework, and again, same question is to rationalize. Rationalize, or the question could also be just simplify. As you saw again, when after we rationalize, the equation or the expression becomes simpler. So that's why we say rationalize, or in some cases the question could be simplified. So 76 is radical 5 and radical r plus radical 8. So in 75, we have a 2 here and a y here. So it's quite similar here, so that's r. So the 2 you're asking about, Fiona, is not here. If 2 was up here, it would be the index of this radical, the invisible 2. But the 2 was down here. That means 2 times the radical of y. Okay, this is talking about example 7.5. Unless that 2 was over here, small 2, this will be the index of this radical. Every radical has the index. If it's invisible, that means it's 2, but it could be another number like 3, 4, 5, or so on. So the 2 was here. It's 2 times this. Okay, so now, let's see how to do this. Again, the invisible radical, the invisible index is 2. We don't have to write it when it's 2. So how do you rationalize this fraction again? What do we need to do?
What's 5 by the conjugate?
That's right. So just like with the previous example here, so we multiply by the conjugate, basically the same thing, by changing the sign. So we're going to do the same thing here. Let's write the fraction again, 3 radical r plus radical 8. And we're going to times this by itself, but we're going to change the middle sign. So plus turns into a minus, and the rest should be the same. And also here, same thing as here will be at the top. Then distribute, multiply, distribute, simplify. So 5, what's 5 radical 3 radical 5? Radical r. 5.
15 radical r.
That's right, 15 radical r. What else? 5 times radical 8. Do we multiply 5 and 8?
No.
No. This one doesn't have a radical. This one has. So basically, just going to write them next to each other. It would be negative 5 radical 8 over, we're going to distribute all this. So if they both have a radical, we multiply them. So radical, or 3 radical r, 3 radical r, what is that equal to?
9 radical r.
9
Maybe r squared.
That's right. Multiply the coefficients here, 3 and 3, it's 9, and r times r. They're both inside, same index, so we multiply them. So we get r. Then radical, 3 radical r times radical 8. What is that equal to? So it's going to be a minus, and multiply what's inside. 3 times the invisible 1, right? 3 times 1 would be 3. And what's inside the radical?
8R.
8R.
That's right. R times 8. R times 8 is 8R. And what's the next multiplication? So we're done with this. This times this. This times this. Now we're going to take radical 8 times 3 radical R. What is that equal to? So again, we have an invisible 1 here. 1 times 3. That's 3. And 8R. 8 times R. And what is the last multiplication? Plus times a minus is a minus. Radical 8 times radical 8 is basically
4.
radical 64. And what else? Back at the top, can we subtract these two radicals?
No.
We can't do 15 minus 5 because this one has R, this one has 8. They're different. It's like having X here and Y. You can't do 15X minus 5Y. They're unlike terms, so that stays the same. What happens to the denominator? What happens?
9R squared. So with R squared, radical R squared, you canceled out and just be R.
That's right. So this 9 stays here. It doesn't have a radical. It doesn't turn into 3. And the index, as I said before, is an invisible 2 here, index for this radical. That means it's a square root, not the cubic root or some other root. So the power here and the radical cancel out. If the power and the index are the same, they cancel out, assuming R is positive. The number R, the question says, is positive. So that's what's left here is just R. Okay, let me write the R better. Okay, so minus.
Those will cancel out.
That's right, these two cancel out. 3, 8 radical R, 3 radical 8 R. These are the same with opposite signs, those cancel out. And what is left here? Minus
8.
8. That's right, 8. So this is an R. Did we rationalize the expression?
Yes.
Okay, what does that mean?
Take the radical from the denominator.
That's right, we don't have a radical anymore. So we had a couple of them. When you multiply it by the conjugate, simplify, these two middle terms cancel out. These perfect radicals turn into basically whole numbers or integers. And that's basically it. So we can't cancel anything else. See here, even though we have 5 as a common factor, right? But here we don't have a common factor. Let's say if we had a common factor 5 here, we could factor 5 here and cancel them out, but that's basically it. That's all there is to it. We just rationalized it. It's no longer, we no longer have a radical in the denominator. It's fine again to end up with a radical here. So the purpose of rationalizing is to not have any radicals in the denominator. You may end up with something without a fraction, as we did earlier here, or you may end up with a fraction as long as it doesn't have radical. That means it was rationalized. Okay, that's the final answer. Okay, guys, understand that? Understand?
Yes.
Okay.
Yes.
Everybody else, you guys got it? We want to hear from all of you.
Yes.
Yes.
Okay. All right. So basically, that's how you rationalize your fractions. Okay. So check out the new lesson plan. Work on your homeworks. Again, the homework is important, along with your attendance here on Zoom and in the discussion forum. We have about 3 weeks left. I'll post the final review sheet sometime soon by the end of the week. Sometimes, I believe. So we've got to work on that because all the topics are summarized in that sheet. and the final exam will be based on it. Okay.
Yeah.
Everyone, is everybody okay? Any other questions for me? Miss?
No.
Okay. What about everybody else? Alva, Faraz, Ruby, Saliha, Shana is here. Fiona is here. You guys all right? You understood everything?
Yes.
I
Yeah.
can't hear from you guys. Everybody.
Yeah, I got it.
Okay. Ruby and Alva. I didn't hear from you.
Yes.
Okay. All right. On that note, have a nice day, and I'll see you guys on Thursday. So keep checking the the discussion board. Watch the videos, the lectures on YouTube. I added a link here to the discussion, to the course resources. If you click on it under course resources, it takes you to the YouTube channel, to the college algebra playlist. I'll be uploading more, including this stuff that we did today. You can rewatch it later if you still have any confusions about it. All right, so thank you all for coming. Stay safe and healthy and all that stuff. And join the discussion forum. Email me if you have any questions. Until then, have a good day and take care of yourself, okay?
Thank you. You too.
Thank you, Professor.
All right. Have a good day.
You too. All right. Thank you.